Let's review. A circle with a dot like that represents a current flowing out of the page towards you, like an arrow coming at you. The X with the circle is a wire going into the page. The current is flowing away from you. It's the back of the arrow. How we find the direction of the magnetic field is a right-hand rule. Your thumb goes in the direction of the positive charge, the current, and your fingers wrap around the wire in the direction of the B field. Now, let's try a little sample here. If you have the circle with the dot, does the field go clockwise or counterclockwise? Your thumb comes towards you, towards your face. Your hands wrap around, and we have arrows in a counterclockwise position. That's the field. What about the X? It's going away from you. My thumb goes into the page, into the screen. It's very awkward. My hands wrap around. Oh, and it's very evident the field goes clockwise. Now make sure that you understand that. Now let's review some of the basics of the magnetic field. The symbol for magnetic field is B. The unit for the magnetic field, Tesla or capital T. The field, the B field, not the current, going into the page, away from you, X's, like the back of the arrow. And the field coming out towards you, out of the page, dots. So, if I had a wire like this, on the right-hand side, do I draw X's or dots? Well, my thumb goes in the direction, my hand wraps around, oh, my fingers are going into the screen. I would have X's. What about the other side now? My hand wraps all the way around. Do I draw X's or dots? Dots. They're coming towards me. Now make sure you understand that. Next, if I have a wire with a current in a field, there's a force on it. It's really pushed. And the way to find the force is a right-hand rule. Your index finger points in the direction of I, index, current. Your thumb is in the direction of the force, and M, middle, magnetic field. And that's what the right-hand rule is for which way it's pushed. So, with this diagram, your index finger points to the top of the screen, your middle finger's pointing into the screen, and your thumb points towards the left, and that is pushed. The force is BIL. B is the field, I is the current, L is how much of that wire is in the field. Now, something new. The strength of the B field around a wire. How strong is the field? What is the field around that wire? Well, certainly it would depend on the current. The greater the current, the greater the B field. Would make sense. And the farther I went away from that wire, the weaker the field would be. So it would depend upon the distance, R in meters. And the formula is B equals mu naught over 2 pi, and it's I, which is the current in the wire. B is directly proportional to I, and inversely proportional to R. The farther I am away, the weaker the field is. Now we'll do questions in another clip. But for now, a very common question is, what is the interaction of two current-carrying wires? Both are carrying current in the direction shown, and to find out what they do, you have to use that right-hand rule and this right-hand rule. You need to make sure, hit pause if you don't know them, and those two right-hand rules will tell you what happens to those wires. Watch. We'll call this wire 1 and this wire 2. Now let's only look at wire number 1. And we say, what is the field around that wire? X is on the right, dots on the left. So, when wire number 2 is there, it finds itself in the presence of a magnetic field with the field lines coming out of the page towards yourself. So I put my finger in the direction of the current. My middle finger points towards my face. And which way does my thumb point? Wire number 2 is pushed towards the right. Now, let's see what happens to wire number 1. So we'll only look at wire 2. And we draw the magnetic field around wire 2, and this is what it looks like. And so wire number 1 finds itself in the presence of a magnetic field going into the page. So I use my right-hand rule, my index finger's pointing up, my middle finger's pointing into the page. Ah, that wire feels a force to the left. So these two wires, when they carry current like that, move towards each other. Now I leave you with this. Suppose wire number 1 has current going in the other direction. Can you show by the two right-hand rules that these wires are pushed apart?